welcome back. So, in last lecture we discussed about the pattern of aerial photography and the information collected for generating the stereographic images, where which can help us in viewing the terrain in 3 dimension. So, this is the if you have multiple photograph collected in the same direction in a line of flight, then you have the overlap here what is been shown between photograph 1 and photograph 2 and photograph 3. So, almost you will have the overlap here of 60% between this, and then you have an overlap of 60% between photograph 2 and 3. And we will look at now a few more important points about that what exactly this photograph can tell us, and how in the future lectures, coming up lectures, we can talk about and how you can even measure the height of any object, because you will be able to view the object in 3 dimension. So, you can also calculate the height of the object and the scale of the photographs, because the scale of the photograph is not available. So, we will talk about how to calculate the scale of the photograph and how to identify or measure the objects in terms of their height and distance. So, advantage of stereo photographs in particular, where we were talking about 30% overlap on sideways and 60% overlap on the in the direction of line of flight. The ground surface and the topographic features then appears in 3 dimension with a sense of depth perception. So, you will be able to make out easily. For example, you are having a valley. So, if you are having an, for example, 2D photographs, you may be able to see something like this, but if you are having a 3D view or 3D vision, then you will be able to understand that the valley is in size or not. And then of course, if you are having a for example, a tree, then you may have a simple point here like this, but if you have in 3D vision, then you will be able to make out that this is having in some height. So, these are the advantages of having, even in terms of the building or in the terms of the terrain, you will be able to sense the area in terms of depth perception. 2 such adjacent aerial photographs are known as stereo pairs. So, if you are having one photograph, and for example, you are having this area here, and you are having another photograph which will also have this information. So, this overlap, having any photograph having the overlap of 60% and 30% sideways are termed as your stereo photographs. So, information recorded on photographs, this is also important. You can extract a lot of information out of that. The following information is recorded on a typical aerial photos. So, one is fiducial marks for determination of principal points. Then you have altimeter recording, at what altitude your aircraft was flying, that also you can record, or the information will be available on the photographs. This I am talking about the aerial photographs mainly. Then watch recording, that is the time at which time or what time you have taken the photographs or the information. Then level bubble, whether your camera was tilted or it was absolutely vertical. Then principal distance for determining the scale of the photograph. So, you can also make out calculate the scale if you are having almost vertical photographs taken, and you can compare either based on that information or the object on ground or on the map. Number of the photographs are important, because this indexing will help us in also putting all the photographs in a catalog, or maybe you can also identify the line of flight. Okay. And that also helps in picking up the photographs, whether the photographs was taken in the particular line of flight. Okay. So, forward, after, forward, after, like that. Okay. Otherwise, you may have a negative image. So, that is also important. And again, indexing the photographs will be important, because you can also index in terms of which area those photographs are covering. Okay. So, you can do that also. Number of the camera to obtain camera calibration report. Okay. So, this will be also available, because this will help us in knowing the focal length of the lens which was been used, and the type of film which was been used on that. Okay. And the date of the photograph. So, this is also you can have on the photograph. So, typical aerial photographs, if you look at, you will be able to see the fiducial marks on either side. These are the fiducial marks which you can see here, and these are built well within the frame of the camera. Okay. So, when you are taking the object or the photograph of any area, you will be able to see this marks on the film itself. So, when they are printed, you will have this marks there. Okay. And if you connect these points, okay, so suppose your frame is having 2 points here, okay, and 2 points here, then this will be your principal point of the photograph. If you are not having this, because some of the frames will not have the center one, okay, then you can connect the diagonal one here, and then this will give you a principal point. Now, why this is important, we will be talking very soon. Okay. So, these are termed as fiducial marks. So, this is an aerial photograph, colored one, which shows what we have already discussed. Okay. So, this is your elevation here, this is the time, and these are the numbers which are been assigned to the photographs. Okay. So, fiducial marks are the index marks rigidly connected with the camera lens through the body and forming images on the negative. That is the frame which we are having, which will create an image on the negative, which are so adjusted that the intersection of the lines drawn between opposite fiducial marks defines the position of the principal point, of the photograph. The lines joining opposite fiducial mark on a photograph are called fiducial axis. Okay. Principal point, a point on the aerial photograph, okay, where a perpendicular from the interior perspective center of the camera lens meets the plane of aerial photograph, or geometric center of the photograph and the intersection of the x and y axis. Okay. So, if you look at this here, this is what you are having, the principal point. Okay. So, this is the plane of your camera lens you can take, and exactly perpendicular to that will be your point on the ground. So, this is your principal point. So, similarly, what we were talking about, that different photographs will have different fiducial mark. Here you are having in half arrow at the. So, if you connect this one So, this are your fiducial marks. Connect this will be, this is your fiducial axis, this will be your principal point. You can also do this to get the principal point. Okay. The edges of the photograph where you are not having the fiducial mark available. Now, stereo photograph geometry, if you take principal point, what we have already discussed is the geometric center of the photograph and the intersection of x and y axis. Okay. The intersection of north south, or we can say east west, okay, of any area. Okay. So, if you are, for example, you are having this photograph here, so you are having, you say east west, north south, you have connected. Okay. So, you have the another photograph, same you can do here. So, different photograph, even though taken for the same area, will have respective principal points, okay, and that will vary from one photograph to another one, but they will have their respective principal points. Now, conjugate principal point are the geometric center of a photograph stereo pair, okay. And this is important because this will help us in identifying the line of flight, and this information will also be useful when we are talking about or calculating the some geometric parameters in terms of height and all that. Okay. So, for example, again let us take this two photographs. We are having the after connecting the north south or the east west, we have a center point here, and same we are having here. So, this what we are having is the principal point of the two photographs, okay. But the principal point of this photograph is not exactly the same of this one, okay, because if you look at two areas here, for example, this one, if you take this object here, it is pointing here, but at this point it is slightly different, okay. Maybe that may be one criteria which we can take, okay. And then you are having the conjugate principal point. So, this is the principal point, this one is the principal point of this one here, which we have transferred here, and this we will term as the conjugate principal point, and this will be the principal point of this photograph. So, say PP1 and this is the PP2 principal point 2, and this will be transferred here. So, this is a conjugate principal point for that photograph, okay. Similarly, you can do here, and you can have either you can say that this is the 2 and this is EPP1 here. And connecting both, okay, that is the stereo pairs photographs and marks of the principal point on each photograph along with their corresponding conjugate points, okay. Line up all points to obtain a line of flight, okay. So, if you connect all this, this will be the exactly the line of flight in which you have taken the photographs, okay. Adjust the distance between the photographs that suits you to get the stereo vision. So, now when we orient this photographs, because earlier in the previous one we were having this photographs just we kept on very straight, we did not even moved or inclined. But after getting the line of flight, okay, because the line of flight is something like this here, okay, if you connect both the conjugate and principal point, okay. Hence, you have oriented this in this direction to get the line of flight. Now, when you will adjust both the photographs and try to view under the stereoscope or by the naked eye, you will be able to see the 3-dimensional view, otherwise not, okay. So, if you would have been keeping your photograph almost like straight as we have seen the previous one, you will not be able to see, but after getting the principal and conjugate point connecting those two, we got that there is some rotation based on the identification of line of light. Okay. So, this will help us in also orienting your photographs properly before you start viewing it. Now, sometime it is extremely important to also look at the huge amount of data which has been connected and try to mosaic. So, this satellite data is again from Corona satellite and they are termed as Corona photographs, Corona satellite photographs, very high resolution. So, what we did was we mosaiced all these photographs and we gave numbers to these photographs depending on the easiest way which was comfortable to us actually. But you can view the overall terrain of the area which, and based on, for example, we name this as an A1, A2, these are the strips. If you carefully see this, these are the connecting points here or the overlapping, then you can easily make out that okay fine, this portion which is printed here like this in the blocks, okay, this will be A1A, A1B and so on. Okay. So, you can easily catalog it properly and then you can take out the photograph of the area which is required, of the area of interest, maybe we can say. So, I will stop here, maybe we will continue in the next one and discuss more about the geometric aspects of the photograph. Thank you.